Okay, everybody, welcome to lesson 4. I hope you're all doing really great. So, first of all, before we start, our guest of honor is right here. Anybody know who that is? This is Buckbeak and Harry Potter. So, I'm going to try to relate every single guest of honor to the coronavirus. So here we go. These guys, Buckbeak and Harry Potter, are going to fly over the city and find out who needs help during these perilous times. So that's what they're going to do right after the math lesson. Okay. Here we go. Notes. Now remember, you can either print these off from the link I send you, or you can just do it on a piece of blank paper, or you can come into the school and grab the printouts, because I'm actually printing them out and putting them in a folder. So you have all those options. All right, so this lesson, we're going to do simple geometric proofs. And we're going to take what we've learned in lesson 1, 2, and 3 and combine it all together. So let's review what we've done in lessons 1, 2, and 3. Parallel lines. You know that they have to have the same slope and different y-intercepts. Okay. The slope, usually we're just going to count it. It's the rise over the run. So let's say, for instance, we have a positive slope like that. You're just going to count, maybe it goes up 3 over 5. Maybe that's what it did. You would say its slope is up 3 over 5. Or let's say we had a negative slope that went maybe down 3 over 2. Then you would say the slope of this one is down 3 over 2. Remember, if it's a positive slope, then your fraction's positive. And if it's a negative slope, then your fraction's negative. So don't forget that. All right, hypotenuse. This is when we use the Pythagorean theorem. It's when you're trying to find the length of that diagonal side right there. That's called the hypotenuse. So since this is a right triangle, you've got a leg here, and you've got a leg here. And then to find the hypotenuse, you're doing this in your calculator. You're going to go square root of leg squared plus the other leg squared. Right? Parallelogram, we haven't necessarily talked about. So here's the criteria for a parallelogram. You need 2 pairs of parallel sides. 2 pairs of parallel sides. So it could be a square as long as this side is parallel to that side and that side is parallel to that side. Or it could be a rectangle. That's a parallelogram. Or it could be a rhombus. Let me see if I can draw a rhombus. Those 2 sides would be parallel. Oh man, that's terrible. Okay, hold on. Forget I even did that. Okay. Yeah, something more like that. Kind of a squished square. Where this side would be parallel to that side, and that side would be parallel to that side. Okay, so those are parallelograms, two pairs of parallel sides. Congruent is the exact same length. So if you have a side and you decide it's 12 long, and then you had another side, and you decided it's 12 long, they would be congruent to each other. So here's the thing, to make a parallelogram, you have to have this, you have to have congruent sides, and you also have to have parallel sides. So that's what you need to make a parallelogram. Congruent sides, parallel sides. Okay, so let's move to a central question. How do I use algebra to show that a quadrilateral is a parallelogram? So let's talk about the word quadrilateral. Quadrilateral is any figure that has four sides. So this says, how do I use algebra to show that a four-sided figure, which is called a quadrilateral, is a parallelogram? And the answer is, well, we're going to show the sides are congruent, and we're going to show there's parallel sides, and then it's going to make a parallelogram. Okay, let's work on that. Page 2. All right. So, I got this example off of Alex. On your Alex, when you do this, you're going to be doing 3 of these. So I'm going to write times 3 because you're going to do 3 of these. And they're all kind of the same, just a little bit different. But here's what you're trying to do. If you can find congruent sides, and, so I'm going to say and plus parallel sides, then you can conclude that it's a parallelogram. So that's what we're looking for. Congruent sides, parallel sides, would be a parallelogram. So on Alex, you're going to get some kind of quadrilateral, some type of four-sided figure. And then they're going to ask you some questions. So in this one, it says, find the length of ZY. Which one? This one is right here. Now, because that's a diagonal, I know I can't discount it. I have to use the Pythagorean theorem. So first of all, I need to figure out how long the legs are. And since it's on a graph, we're just going to count it. So 1, 2, 3, 4, 5, 6, 7. This vertical leg is 7. And the horizontal leg, 1, 2, 3, 4. All right. So, and that makes a right angle. So now we're going to use the Pythagorean theorem over here. So you're going to do square root of 4 squared, that's a leg, plus 7 squared, that's the other leg. Now here's the thing. In Alex, they want exact answers. So if you do it like we have been doing it, 4 squared plus 7 squared, in the square root, you're going to get this long decimal. 8.06257748, on. Alex wants exact answers. They don't want a decimal. So what you're going to do is you're just going to do the inside piece and not do the square root, because it's the square root that's turning it into this decimal. So if you just do 4 squared plus 7 squared, that gives us the middle part, the inside part. So square root of 65, that's how Alex wants it. That's an exact answer. This right here is a decimal approximation. So you need to remember that. I'm going to write exact answer. We don't want any decimal approximations. Okay. Then the second thing says, find the length of WX. So WX is that diagonal one right there. So we're going to use Pythagorean theorem again. We're going to find the legs. We're just going to count them. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4. It's exactly the same. So it's the square root of 4 squared plus 7 squared equals, we already did it up here, so we don't have to do it again, square root of 65. Okay, now this is something we need to know, because those two sides turned out to be the exact same length, which means they're congruent. So right here, you're going to put same length equals congruent. And that was one of the things we needed up here to prove it's a parallelogram. So we're halfway there. Okay, the next thing, we need to find the slope of ZY. Well, that's super easy because we've already drawn it out. Up 7 over 4. Remember, it's rise over run. So up 7 over 4 is the slope. And the slope of WX, up 7 over 4, exact same thing, up 7 over 4. Well, that's significant because the same slope makes them parallel. So same slope equals parallel. All right, which is good because that's the other thing we had to figure out. Now we know they're congruent and they're parallel. So after you get those two pieces done, on Alex, you're going to have this big thing right here where you have to figure out what answer they want you to choose. Well, if you look for the word both, that's a key word because it's a parallelogram because there's both congruent, which we figured out right here, and parallel sides, which we figured out over here. So that's the answer. Okay? All right, so there's one example. You're gonna do 3 of these on Alex. And it's due April 9th, which is a Thursday. For full credit, late credit would be by midterm on April 17th. Okay, so if you're in regular math, you can stop the video right now because that is the end of your part. If you're in honors math, you get one more section. So here we go for the honors section. All right, honors section, a few more things. Perpendicular. So perpendicular is when the two lines meet together at a 90-degree angle. And that is when the slope has to be an opposite inverse. So for example, if one of them has a slope of 3/4, then your opposite inverse is going to be negative 4/3. When that happens, you know you have 90 degrees. Okay, a definition of a rectangle. A rectangle has to have 4 90-degree angles. So a rectangle would be something like this, and it's going to have 4 90-degree angles. Or it could actually look like a square, because a square also has 4 90-degree angles. So a square is a rectangle. Okay, a rhombus has to have 4 congruent sides. So let's see, I already know I have a hard time drawing a rhombus, so I'll give it a shot again. There. Okay, so that could be a rhombus if that side and that side and that side and that side are all the same length. But a square can also be a rhombus because that side, that side, that side, and that side are all the same length. Okay, but to be only a square, you need 4 90-degree angles and, very important, 4 congruent sides. So a square has more criteria than the other two. So you're going to have 4 90-degree angles and 1, 2, 3, 4 congruent sides. All right, so on your Alex, you're going to have 3 of these also, where you're going to try to decide, is it a rectangle, a rhombus, or a square? Those will be your choices, or none. Rectangle, rhombus, square, or none of these. So you're also going to get a graph and then some criteria you've got to figure out. So this one says, what is the slope of GH? Which is this piece right here. Since that is a diagonal line, we're going to use the Pythagorean theorem. So up 2 over 7. So 2 and 7 are the legs. Oh, we're looking for the slope, sorry. Slope, up 2 over 7. Up 2 over 7. Okay. Now, slope of side adjacent to GH. So let's do this one right here. This one's up 1, 2, 3, 4, 5. Up 5 over 2. Up 5 over 2. Okay, now this is significant because these two slopes are not opposite inverse. So I know these two slopes are not meeting together at 90 degrees. I mean, it's obvious from the picture, but if you use algebra, you can see these are not making a 90-degree angle. So because they're not making a 90-degree angle, it can't be a square and it can't be a rectangle. I already know that. So I'm going to say, well, it can't be a square because they're not 90 degrees, and it can't be a rectangle for the same reason, not 90 degrees. Okay, so we've ruled those out. Now let's do the length of GH. Well, we already know the legs are a 2 and a 7. So square root of 7 squared plus 2 squared would give us some crazy decimal. Remember, we want exact answers. Alex is only going to let you put an exact answer in there. So you're going to do just the inside part. 7 squared plus 2 squared equals 53. Because it's the radical that's making it be a decimal. So you're going to leave this as square root of 53. That's the exact answer. Okay. Now, side of the one adjacent to. So we're going to use this one right here. The legs are a 5 and a 2. So square root of 5 squared plus 2 squared is square root, that's 25. That's a 4, so that's a 29. Okay, this is significant because they're not the same length. So they're not congruent sides. Which means if they're not congruent sides, it can't be a rhombus. So you go over here and you're like, well, it can't be a rhombus, not congruent. Of course, then it couldn't be a square either. So in this particular case, it's none of these. But you're going to have 3 of these to figure out on your homework. So good luck. As always, please email me if you get stuck on something. I love to help you, and I hope all you guys are doing great. Bye.